name is
Yes.
Pramod. I'm based out of Ireland. I work for Microsoft as a cybersecurity architect. I work for service providers specifically. Um, I also wrote a book earlier this year on 5G security, and I
Yeah.
also work with NIST, which is a standard organization, and with the NATO cybersecurity or defense. And I also I'm a guest lecturer at New York University for the fall course of cybersecurity. And I'm
Yeah.
very excited today to talk about cloud and multi-cloud. Before
Yes.
joining Microsoft, I was with Cisco, Motorola, Qualcomm, and all those different companies. But today, it's very exciting to speak about the cloud and the multi-cloud story, Kate.
Yes, actually, our today's topic is really exciting. It's centralized security in a multi-cloud world. It sounds like a topic, like a theme of some, I don't know, Marvel movie or something, some multiverse, multi-cloud world. So please, could you tell me why it's important to discuss it today? Why each part of this topic is really important?
Yeah, so um, all the enterprises, mostly all the major enterprises, are going towards cloud, not because there is cloud, because there is efficiency in terms about cost, in terms about manageability, on automation and scalability, right? So if
Yeah.
you look at any of the enterprises and their go-to market, the time really gets optimized if they're going towards a cloud model, not
Yeah.
only because it can be deployed easily, but because it can be deployed securely. That is one part.
Yes.
Second, there is also a need for multi-cloud security, right? Gone are the days where you would have one control or multiple controls for a single cloud. We are speaking about vendor agnostic security controls, which is very important these days, and cost efficient as well. I'm sure we'll speak more about what do we mean by cost efficiency in terms of security,
Yeah.
but that's all is tied very closely with innovation and the evolution what we are seeing in the cloud deployments.
Yeah. And actually, that's my next question. What changes and what kind of evolution you see in
Very
cloud?
good.
Because it is like we see that there is like huge changes everywhere, and there is like more companies go into cloud, but not every company understand how it changes through time. So please tell
Yeah,
us
very good. So
more about it.
let's take a step back, right? All the
Yeah,
story comes from virtualization, right?
yeah,
If you talk about virtualization, it came up in 1960s thanks to IBM, right? And
yeah,
today we are in 2022 where we are having a look at different kinds of virtualization. So
yeah,
the kind of virtualization today we are speaking about serverless deployments. And when
yeah,
I speak about serverless deployments, I'm not speaking about a virtual machine or a container or
hmm,
a deployment without server. No, serverless means that all the manual work of which is linked to a server is taken off, and what we are talking about is a dynamic environment where you deploy a code, copy a code and paste it, use it in AWS Lambda, use it in
yeah,
Azure Functions, use it in Google Functions, does not matter. And then you pay only when that code is run into a dynamic environment. A container is created, it runs on that for that application, and it gets destroyed, and you pay only for the time when that specific container is run, right?
yeah,
It's very different from the model we have today, where or yesterday, where you had to pay for the compute, for the storage, or you have an on-prem server and things like those. So that is one big evolution in terms about virtualization. So virtualization of yesterday is not of today. That is a big evolution, right?
yeah,
Second is the evolution in threat attack vectors. What do I mean by that? If you look at various threat attack vectors till today, it's quite wide, right? But people were thinking that, okay, I can use a web application firewall or a firewall or an IPS system and then secure my network on those deployments, right? But if you look
hmm,
at the deployment layers going forward or the threat surfaces, what we are seeing today, whoever has identified those threat vectors or vulnerabilities has got a beautiful mind, right, and a very
yeah,
curious mind. So we cannot say all the people who identify those vulnerabilities or understand as a vulnerability as hackers. No, right?
yeah,
They've got a beautiful and a curious mind. People who use it for malicious purposes are malicious people, right? But
yeah,
if you look at the threat surface, what we speak today, and why we are speaking about the cloud stories, because many of the threat surfaces require the entire hardware stack to be removed, which means
Yeah.
that they have to remove their existing servers, their switches and routers. They're speaking
Mhm.
about attack surfaces like row hammering. I'm sure
Yeah.
you all know, but I'm obliged to state it. An example of row hammering or how it works is that each of the memory has got rows, right? And the electrons are on the rows. The
Yeah.
way the attacker is now attacking certain systems is not at the application layer, but by
Yeah.
hammering these rows and by making the electrons hot and changing the charge of the electrons so the data
Yeah.
becomes corrupt. So the only way we can actually mitigate these threat surfaces is
Yeah.
not by putting firewalls or things like those. We have to remove the hardware and have the chipsets in place which cannot be manipulated for these things. So, for an example, Microsoft last year invested 1.2 billion in churning out the data centers and things like those. And
Yeah.
because we have this capacity of the data centers being upgraded, moving the components of all these web applications to the cloud makes more sense because we have invested already in those kind of security mechanisms. We have
Yeah.
churned out the data centers, putting in new stuff and things like those. The third thing, what we are seeing is primarily API communications, right? So if you
Yeah.
look at all these DevOps model and all the
Mhm.
models, many of them are based on API controls, right? And API is not new, right? But the way the attacks on the APIs are being done is quite different. If you take a look at the top 10 OWASP threats, the way the attack surface has evolved is quite crude in a way. What do I mean by that, right? Let's say I want to attack an API interface. I give a request knowing that I will be not accepted or authorized into it. But then I
Mhm.
get a reply back, a response, it's called,
Yeah.
with a small thing on the left corner saying that this message is from Tomcat Apache version 3.1, for example,
Mhm.
right? That is enough for me. So I will take that information,
Yeah.
Tomcat Apache version 3.1, go to the outside world at the internet, look at the vulnerabilities, and come back and attack your server with those vulnerabilities, right? So, what
Yeah.
I'm trying to say is that because API use has been increased, the
Mhm.
way the virtualization has changed, the way the threat surfaces has changed, it requires us to think about security a bit more. And when I say a bit more, not just by investing on security, because sometimes just investing more on firewalls or web application firewalls is not the answer. The answer might be an architecture where you there's a well architecture framework in place. All the cloud providers, right? Azure, AWS, we all have our well architectured framework, and we make sure that the security underlying is pretty much solid. So we
Mhm.
from Microsoft has built this well architectured framework where security is a foundational layer. It's not an added on layer, meaning
Mhm.
which each and our data centers also go through various vulnerability assessment and things like those, including
Mhm.
automation, which is very important, which I'll come to it in a second. So hopefully, Kate, I've given you some key areas where we
Yes.
see the innovation happening, the evolution happening, and why cloud security becomes more important.
Yes, thank you very much for that detailed answer because actually last week we have a panel. You know about this panel.
Yeah, yeah,
Actually, it
yeah,
was
sure, sure.
about like on-premise versus
Yeah,
cloud. And
yeah,
we talked also about security on that panel. And one speaker said that security has so many layers, levels. So actually, I would like you maybe touch this topic also a
yeah, sure,
bit
great.
more because you can describe, we didn't have time for that at that panel,
Oh,
but
yeah,
maybe
sure.
you can describe like different levels because it's your like specific knowledge in it,
Yeah.
like you are an expert. So
Uh,
could you
yeah,
please
I'll
like
not, yeah.
specify a bit? Yeah.
Thank you, Kate. I am learning every day, Kate. So I will not call myself or anybody in this industry an expert at on attack or threat surface because we learn every day. But I
Yes.
like that question, right? So let's take a step back, right? So on premise is always going to be there. It's not going to be vanishing because many of the
Yeah.
use cases, including if you look at service providers like
Yeah.
Vodafone, AT&T, Verizon, Geo, and all these service providers, as per country regulations, they might need some of the workloads on-prem for lawful intercept and things like those. Many of the enterprises for their edge compute layers, they actually might need a hardware on-prem. Can be a one RU, one rack unit server, with some applications on top of it. What do we mean by multi-layered security controls, right? So every person can have their own view. But if you
Yeah.
look at the architecture stack, when we say multi-level or multi-layer, we start from the networking layer to
Yeah.
the application layer. I'm sure you know, but I'm obliged to state it. Whenever we deploy any network, okay, be it in a cloud. So cloud is somebody else's computer, which is somebody
Yeah.
else's data center, right? It's Microsoft data center, for example. Even there, we need to have the multi-stack layers. Let me give a
Yeah.
small example. When we build a networking layer, we are speaking about layer 3 devices like routers, and we have got L2 devices like switches,
Hmm.
we have got aggregation routers, we have got a hardware stack of x86 servers, we have got the top of the rack switch, we have got various IPS IDS systems. Then from there uh, it goes to the user level. So that is the networking layer. For the networking layer, you will need things like end-to-end visibility, right? You need to
Yeah.
understand the flow of the packet, and you need to stitch the flow of the packet to understand where the packet is coming from, where it is going, the lifetime of the packet or the lifeline
Yeah.
of the packet. You should have that visibility. That is the networking layer. It includes things like access control. What do I mean by that, right? I'm sure you
Hmm.
know, but I'm obliged to state it. Normally, when we say access control, we speak about multi-factor authentication and zero trust access, which has
Yeah.
been abused in marketing lingo all over the world, right? But what
Yes.
do we really mean by that is that, let's say we've got multiple vendors deploying their layer. Each of the vendors should have access only to their layers, right?
Yeah.
That is one idea of having a layer of access control, because why should I have access to somebody else's equipment, for example?
Yeah.
The problem is not sabotage. The problem is that unintentional misconfigurations, for example, and this
Yeah.
could be avoided by having that kind of a zero trust access.
Hmm.
Again, on zero trust, the next layer is, let's say I am a subcontractor for a vendor. Okay, I work in
Hmm.
multiple projects all around the world. Okay, so in my 20 years of my experience being in Microsoft and Cisco and Ericsson, Qualcomm, Motorola, Nokia, whatever, nobody has asked me, Pramod, during the project, how many security controls have you catered for? The only thing they
Yeah.
ask me is when the project is going to be completed. So the program manager or the project manager does not look at security. It is the responsibility of the vendor and the service provider or the enterprise to ensure that the access controls are clear. So we
Yeah.
have catered for network access. Then we're speaking about user access now, where we're speaking about user access on applications, on servers, on the network layers, and things like those. Then the
Hmm.
next layer on top of that is actual application layer. So
Yeah.
here is where you need things like cloud access brokers. Why? Because it is API communications, and you could have APIs to a command and control server, which can then launch a application level DDoS, not a network level DDoS,
Yeah.
application level DDoS attached to your network. So that becomes the application layer and things like those. So there's multiple stacks. We can now, when we speak about the application layer, the way you deploy the application is very important. What do I mean by that? Are you deploying a virtual machine? Are you deploying a container? Are you deploying a serverless code? So that is also very important, because when we talk about things like Istio for service mesh and things like those, we should make sure that we have got visibility on those Istio components as well. That
Yeah.
can be achieved by taking the sidecar components of the Istio service mesh deployment and giving that visibility layer. Last but not the least, when we talk about the end-to-end visibility, it is very important that we kind of understand the efficacy of the
Yeah.
network. What do I mean by that? Let's say you have got 1000 events. Out of those 1000 events, maybe 10 or 50 or 100 are the key
Yeah.
kind of events which we should know. So what we have done behind the scenes, Kate, is we have created the SIM of the SIMs, the
Yeah.
SIEM, the SIM, where we make sure that we look at close to 600 billion events per year, right? And we
Yeah.
focus down that to close to 500 events per month, which should be catered for. So when we look at the multi-layered security stack, having the capability to filter out all the noise and give the actual anomaly detected signals back to the team to work becomes very important. So sorry, it was a bit of a long-winded answer,
Yeah.
but the
It's okay.
multi-stack, yeah, the multi-stack is very interesting, And here is where you will need multiple layers of security
Yeah.
control. So in short, there is not one silver bullet or a silver security control which is going to solve the problem. Most of them depends on the use cases
Yeah.
and where they're going to deploy. If the defense system has got a completely different set of requirements, compliances. The healthcare has got a separate
Yeah.
requirement. So, but we from Azure, what we are doing is that we are looking at the industry requirements for
Mhm.
compliancy and then mapping them to the industry level areas so that we can make sure that not only multi-layered security controls, but also compliancy level is required.
Yeah.
Third, but not the least case.
Mhm.
So when we speak about multi-layered security, apart from compliancy and multi-layered security controls, what I've seen many people might oversee is actually looking at the consultancy services. What do I mean by
Yeah.
that, right? Let's say you're a big enterprise and you have got worldwide deployments of your branches and headquarters just by buying products, okay, be it from any vendor, right? Even Microsoft, AWS, does not matter. Investing billions in a security product will not and does not solve the problem. What you actually need is a level of a consultancy services where somebody comes, understands your architecture, understands what are the gaps in the architecture, and then understands security requirements and gaps in security requirements and come out of it. For these kind of
Mhm.
things, automation is very important. And
Yeah.
I think in areas of these is where Acure can really play a very good role. We have to start working very closely together going forward with you and the
Yeah.
team. But the point is that uh, looking at the security architecture, building blueprints is very, very important. And
Yeah.
from Microsoft, we have got a security services line where we work a lot on the security architectures. And we're trying to tell the customer that before you invest millions in security products, you might be able to reuse most of the security products for the cloud deployments as well. And that
Mhm.
is the area we are trying to advise our customers on.
Yeah. Thanks a lot for such detailed answer as well, and thanks a lot for mentioning us. And we will talk about automation a bit later, but let's clarify. Maybe you talk a bit about it, but maybe we can clarify like key differences between on-prem and cloud deployment in terms of security. So
Sure,
from
sure.
security perspective. Yeah.
Sure, yeah. So when we look at the on-prem deployment, we are all very much used to things like VLANs,
Yeah.
virtual networks and things like those, having IP addresses and things like those. When we look at the cloud deployment model or even cloud native deployment, meaning which it is a component which can be deployed on-prem
Yeah.
on a hypervisor, can be ESXi, can be KVM, or can be deployed on some Azure or AWS or Google components as a bare metal kind of a concept or on top
Mhm.
of a ESXi as well. The big differences which the enterprises or the customers will see is that the concept of isolation is quite different on the cloud. What do I mean by that, right? Let's say you're deploying on-prem, you've got your own hardware,
Mhm.
you know this hardware is for you and you only, right?
Yeah.
Your resources, you've got everything. But the issue there is that once you have some kind of a threat, like the row hammering,
Yeah.
only solution you have is remove that entire server and put in a new server, right?
Mhm.
Nobody changes their servers every year. In the 20 years of my experience, I've never seen my customers changing their servers every year on the data center. It never works
Yeah.
that way. We all know that, right? Sometimes
Mhm.
5 years, sometimes 70, sometimes even 10 years. There's a switch in many data centers which people are afraid to touch because their network is working and they don't want to touch
Yeah.
that switch. For 10
Don't
years, right?
don't
It's
touch the
blinking
network.
green.
Yeah.
Yeah. Yeah, it's blinking green, and people say, okay, thank God it's working.
Yeah.
But the point is that when you start to evolve your network, evolve your use cases, your customers increase, you need to have a scalable model with isolation as well. What do I mean
Yeah.
by that, right? So Microsoft, for example, depending upon the use cases, also allow hybrid deployment models. For
Yeah.
example, on the telco area, where we have got our
Mhm.
telco deployments, where we work with big
Mhm.
service providers, right? You can name any service provider, we are working with them, right? Recently, we also moved the entire AT&T mobile network onto Azure. We're working with other service providers as well. So there, the concept of hybrid is very much required. So what is Microsoft doing there is that they're deploying our on-prem servers as well. And even other cloud vendors also have that. And then we have got a hybrid connection up towards our cloud deployment model. So here the concept of VLAN is gone actually. Now we have got virtual networks, right?
Yeah.
It's a logically isolated component within the data center. So we have got hundreds of data centers spread across the world, right? Let's say you are from, there is a deployment in Norway, for example,
Yeah.
and they need a local data center. So we have got data centers in Norway as well. And what
Mhm.
we do, instead of using VLAN, we will be using IPsec from the on-prem deployment up to the cloud, and the cloud will build a logical separate isolation for that specific customer. And the
Yeah.
customers can choose what data center they want on what part of the world and availability zones as well. What do I mean by that? Let's say they have deployed a certain image in the north of Norway, and they want availability zone in the south of Norway. What do I mean by that? If the north data center goes down, then the south data center can still cater for that. That's why it's called as an availability zone. It is
Yeah.
available for you if one of the key data centers goes down, or the link goes down, something
Mhm.
bad happens, right? So there now the concept of resiliency is better for the cloud deployment
Mhm.
model, because you can have multiple availability zones across the world if you want, right? So that
Mhm.
is a great concept on the cloud deployment model. The second layer where we have to work very closely with enterprises and service providers and many of our customers is the concept of cloud security is a shared model. So
Yeah.
the security of the data center, security of the applications is Microsoft's responsibility. But let's say you have to provide access to an employee A or employee B, that might be your responsibility, right? So
Yeah.
because you have to decide who needs access to those workloads. So that is how we are doing. The third layer is to have a look at the way you look at security itself. So when we look at the cloud security, uh, we have got the entire security infrastructure built. This is now not for all cloud providers because
Yeah.
some of them don't have it. But
Mhm.
from Microsoft, what I can say is that we we provide the entire security stack already. So you need not buy 10 firewalls, 5 firewalls, or this and that, rack up the stack, management, operability, upgrading, and things like those. We take care of that. We've got a license bundling on E3 and E5. Most of the controls come as a part of the bundle and can all stack that up. We also provide the visibility layer kit. So
Yeah.
let's say you are deploying on-prem, you will have visibility of the on-prem, right? But the cloud, you might not have the visibility of the cloud because your entire estate of the SIM is on-prem. It
Yeah.
might not have connectors on the cloud. And if they need connectors on the cloud, we need to work with vendors, which we have partners. We have got very close SIM partners as well. So from the
Mhm.
cloud perspective, what is a differentiator here is that many of the controls come in the cloud already,
Yeah.
right? It's up to you whether you want to choose those controls. For example, right? We have got anti-DDoS. Okay, we have got also DNS security, right? We
Mhm.
have got firewalling. We have got web application firewall. So it's a matter of not investing a lot in boxes, but activating the features. So the concept of security that I need a vendor to be deployed, that goes off. Now the concept is mostly of what features should I activate, what features should I need, where I need the visibility. Gone are the days of I need a connector for this application on the cloud. Because it is our own cloud, we have the connectors ready made for all the AKS. An example would be, let's say you're building up Kubernetes clusters. We have got AKS, right? We got Azure Kubernetes service where you deploy all the Kubernetes services. We can give the visibility from the AKS directly. So those are some of the concepts, and we can go into more detail on the
Mhm.
cost savings, which I mentioned
Yeah.
that we invested 1.2 billion and things like those. We do that on every 12 to 18 month cycle case. So every 12 to 18 months, we try to churn out the devices in separate data centers where we feel that there are some vulnerabilities or things like those. Now, the fourth part is mostly about onboarding of applications, right? So the on-prem model, even though this concept of CI/CD, continuous integration, continuous development, you don't have much of the dynamic application testing or static application testing. It requires a separate team. You need to have the right kind of experts and things like those. Microsoft bought GitHub. We
Yeah.
acquired GitHub. We were the entire storyline there, right? And we do the CI/CD for our own kind of applications as well. And we do something called as SBOM. It's called as Software Bill of Materials. I'm sure you know Button Mobile just stated. Whenever there's a cloud native application which is open
Mhm.
source, it will have all the open source applications like Python, like Ruby, Golang, Node.js, and things like those. We have got the version numbering for those, and we look at all the vulnerabilities. So we are talking not only about taking offloading all those things from the on-prem deployment models, but cloud as such is very dynamic model, and the way the industry is going is towards serverless models. So now we will have to look at how a when you copy paste a code, does the code have any malicious links or going down to some command and control servers? All those things we are taking care of as well. So in short, when you move towards a cloud model, there's a shared responsibility. There
Yeah.
is also a bit of peace of mind because um, all the cloud platform vendors, they've invested a lot on security, and Microsoft specifically, we have built it on security as a foundation. So they might have a bit of peace of mind that they're following in an architecture which has catered for a lot of threats already, right? We can
Yeah.
never say that any cloud platform provider is will never be hacked or things like those, because as we're told, we are learning every day and we are evolving every day. So, Kate, hopefully that gave you a perspective
Yes,
of what could be
definitely.
a key differentiators, yeah, of this.
Yeah, definitely. Thanks a lot because you so detailed like describe each level of this like huge dilemma where to go, like to cloud or on premise. And I have like one more question in this in similar topic, I think. What do you think about differences from security perspective as well between private cloud, on-premise, and off-premise? So we talked mostly about like cloud versus on-premise, like servers versus cloud, but it's like different kinds of. So maybe you can also a bit like add a bit information about it also.
Sure, yeah, and this concept of private cloud and the public cloud and semi-private cloud or a
Yeah,
semi-public cloud has been
yeah,
floating around
it's
for a
yeah,
while, and we're seeing that a lot on the service providers now.
yeah,
What do I mean by that? So all these mobile providers, they are looking at different types of monetization use cases, which is very
yeah,
much linked to the way you deploy the cloud, right? What do I mean by that? So let's say we have got private deployment layers of 5G, right? We
yeah,
call that, there are two kinds of private cloud deployments in 5G. It's called as SNPN or PNI NPN, which means that
yeah,
standalone non-public networks.
yeah,
PNI stands for public network integrated non-public networks. So this is very similar concept to the enterprise private 5G or private cloud deployments as well. The
yeah,
way we see that is it's very, very use case dependent.
yeah.
For example, if you look at many of the critical infrastructures,
Mhm.
so what Microsoft is doing there is making sure that we have specific data centers for critical infrastructure providers only.
Yeah,
And we got different namings for that. We call that ACI and things like those. So for those kind of deployment models, it is very, very specific to defense and to critical infrastructures like energy, utility, and things like
yeah,
those. So that is, I think, a good step to think. So if any of the audience here is from the energy sector or from the critical infrastructure, it will be very, very useful for them to understand that the deployments require a bit more extra security control, a bit more isolation, and in layman terms, air gapped, which means it is not open to all the worldwide internet and things like those. There are certain
yeah,
restrictions in place where we ensure it's taken care of. Public cloud is for all the web servers out there, right? So I mean, any of the, if you want web hosting or you want to have streaming and things like those, we are also working with Netflix, with Disney, for example, and we are creating that kind of an ecosystem where we have the time to market is kind of reduced and things like those.
Yeah.
So if you look at the security requirements for these different deployment models, it is very, very use case specific. So for
Yeah.
critical infrastructures, one of the key controls is user access, and not just MFA, but they're speaking about cloud entitlement management and things like those. So we have got different security controls and requirements based on use cases. But one of the key things where public deployments are now we are seeing a widely used is for security monetization. So let's say you are a customer who is looking for security monetization. We're seeing a new concept of B2X, which means that it has got B2B, business to
Hmm.
business,
Yeah.
B2C, business to consumers, and then we have got B2B to B and B2B to C. So we've got
Yes.
different models coming up in the market. And here
Mhm.
is where we see the public cloud deployment more suitable for them than having just private 5G, because we have got things like network slices of control and things like those, which is actually going to help a lot of enterprise customers as
Yeah.
well. So um, from the security point of view, it's purely use case by use case control. And
Yeah.
for critical infrastructures, we'll be having a few more added security layers, which is very, very uh, restricted or very, very strict security policies.
Yeah. Thanks a lot. Actually, it's quite clear right now how it's not like clear, but it's actually more understandable right now. That's really like really so much differences based on use cases, and it is beautiful that you have all these varieties of how you can like use like different types of cloud, different types of environments. So yeah, it is great.
Still learning, kid. I'm still learning. So we all have to learn. We
Yes.
all have to live and learn. So
Yes, actually, I can say that at our events, I learned so much each time. So thanks a lot for your knowledge. I'm just like under under impression. So I think the next like really important question we need to discuss it's cost of like cost effectiveness of cloud and security, and also we discussed before in our call like the cost of advantages. So maybe you can also describe it in a couple words at least,
sure.
because it's the main question I think we're discussing with our customers when we're talking about like cloud environment, cloud infrastructure. So they like talking about really high prices, and we need to understand how we can
Yeah,
make it
sure.
effective.
Sure. So I'll give you some of concrete examples and then give you some overlaying kind of examples as well.
Yeah.
So if you look at the basic uh, cost of data centers
Yeah.
and having the right kind of resources for
Hmm.
security, for deployment, for operability, for manageability, and things like those, that is pretty high, and it's just getting higher. It's not getting lower anytime
Yeah.
soon, right? The second thing is that the 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 efficiency of those data centers. What do I mean? Let's say we have got customers who invest close to 35 million each year on data centers, okay,
Yeah.
and we're trying to shift that to the cloud, because the point is that, let's say you, for security point of view, you have got firewalls for IPsec, call that side to side VPN or RAVPN. You've also got firewalls for the ACL configurations and port filtering and things like those. You also have got layer 7 firewalls for the application level firewalls and things like those. Then you've got IDS and IPS systems, intrusion prevention systems, do the DPI and things like those. Then you've got SSL kind of firewalls where you look at the inspected package, you break the package, look at the things and things like those. So a
Yeah.
lot of things on the firewall estate as well. Then we go towards and look at the visibility layer, you look at the anti-DDoS mechanisms and things like those. None of them is used 100% all the time, not even
Yeah.
75%. So my point is you're investing a lot of estate, which is required. Don't get me wrong, it is all required.
Yeah.
But because of the normal way we work, it is never 100% utilized. Some are utilized 10-15%, right? We have worked in industry for 20 years. We know what goes on. So
Yeah.
many of the firewalls are 10-15% kind of utilized today, right? And they invested millions in it, really millions, right?
Yeah.
So one way to look at things is efficiency of where you're investing, right? When we look at the cloud model, you don't just say, okay, I want a firewall of 100 gigs. No, you just say we want a firewall, and depends upon the consumption of the firewall, it automatically scales. It depends on license, right? It scales. If you need 100 gigs firewall, it will scale to 100 gigs as well, giving you CGNAT capabilities and all those things because it's deeply integrated. And you also don't have to worry so much about applying patches and things like those because all these things are catered by the patches from Microsoft already. Let's say you are using Azure firewalls, for example, or Azure web application firewall. The patches are done automatically. In many cases, it's not even a patch. In a container, you don't apply patches, right? You destroy the container and recreate a new container. That's all thing is happening behind the scenes. That is a big part of the cost efficiency. Third one is things like SOC, right? If you look at the traditional SOC layers, many people have deployed SOC. They need SOC. Okay, they can have Splunk, QRadar outside, and all these, even Sentinel in some places where we have the SOC, and it's very resource intensive. You will need number of people for the morning shift, night shift, senior analyst, junior analyst, senior architects. A long story. It's not an easy thing to do. It's a resource
Yeah.
intensive, and again the cost is on the resources, right? So what we have done, we have seen all those layers and we have tried to automate many of the functions on the SOC layer. So here is where automation becomes very important, right? So when we speak about automation, we have got many of the vendors just say we've got APIs, right? APIs is not automation. API is a
Yeah.
method to automation. You need to invest in resources and create coding for those APIs to work all efficiently and things like those. There are many APIs, I'm sure you know, but I'm obliged to state it. When I say an API call on a software model, there's something called as a MOM, Manage Object Model. That
Yeah.
Manage Object Model has got a parent and a child. Under the child, there are a list of API parameters, which the API call can go and fetch those parameters. Many of the vendors, they don't expose all of those child parameters, meaning which even if I have an API call, I can't access those parameters. Now, I'm a developer, I have to work with that vendor or create my own API call or a get or a call push using different models and then pull those APIs, right? So it again requires investment. So what I'm saying is that when you go to the cloud, you will see that the first couple of weeks you're a bit confused as to what is going on, how did we are not doing that, we are not doing this. But eventually you will see that many of the stuff which is to be done by resources on-prem, we have automated most of them on the cloud, right? Including security policies, templates are present there. You need a playbook for certain SOC mechanisms. We have provided that. So you will see a big cost efficiency on that part, and you will see a big cost reduction on your data centers. As I told before, the on-prem deployment model is not vanishing anytime soon. It will be there. But instead of people investing 35 million each year, it might go down to 5 million or 2 million because many of those components and the responsibilities lie with the cloud provider. So these are the very pragmatic examples of how the cost actually moves or reduces, and the efficiency is higher because now you're paying for what you use. You don't pay for a box for 100 gig capacity which is not being used. So if you look at a price per gig, you're paying more when you deploy an on-prem resource. So I think these would be some concrete examples, Kate, when we look at cost efficiency in the point of resources, operability, manageability, and the scalability part as well. And scalability is very important because when the scale is required, it's not only the data center, not only the workload, you also need to improve the backhauling, you need to improve the peering, you need to improve the bandwidth you're giving to that data center as well, Whereas in Microsoft, we have got the good holistic fiber network, which has got a good capacity as well. So you will not face the issue of capacity or issue of improper security controls when you move towards a cloud, because you're paying on the feature level, not per box level.
Yeah, thanks a lot. Actually, I I just can't add anything actually. And let's talk about automation in this case, because
Yeah,
you touch it like in
yeah,
every answer you're talking a bit about
yes,
automation.
it's
And
very important.
me actually, from like automation platform, I'm really curious, what do you think about it? Is it like a really huge trend, or is it like slowly growing? Or maybe you can like also tell how you personally use automation in your work.
Yeah, sure. So if you look at the use cases for automation, it is unlimited,
Yeah.
right? Um, but we also have to see, what do we mean by automation,
Yeah.
right? Uh, uh, do we mean just having two components talk to each other when required without having a manual intervention? Are we speaking about provisioning? We are speaking about deployment, or are we speaking about doing some smart and cool things where it has some AI and machine learning built into it, so that it can be done properly? So, taking a step back, I can split automation into two or three areas. One is simple automation, one is semi-smart automation, and third one is really smart automation. What do I mean by that? In a the toppest bracket of smart automation is where I am really interested and focused on. What do I mean by that? So let me take one example of end-to-end visibility, monitoring, threat
Yeah.
detection, and threat mitigation, right? If I look at the visibility layer, if I have got the capability to connect to different data connectors, be it a NetFlow, CFlow, JFlow from all the boxes, we're speaking about sidecar components from Istio, EXXI metadata, so on and so forth. Instead of having a manual bulk configuration and pushing that out, I have got some kind of a call or some kind of a mechanism, even Yang models, for example, where we can pull all these data and collect it. That is some sort of a smartish way. It's not fully smart yet, smartish way, where an automated way of log collection and monitoring is done, right? But that
Yeah.
is not enough today. So now today we have to use that information in a very smart way, where we come out with some recommendations for the user. For example, what we can do is collect that data, run certain supervised or unsupervised, depending upon the use cases, kind of a machine learning there, and where we filter out the majority of the noise and come with some small sampled outputs. Those sampled outputs have needs to be run through some kind of a engine which knows what those samples are. So, for
Mhm.
example, let's say we are working on a big enterprise and we want to find anomaly. What is a way to find an anomaly? The first way is to understand what is normal. Once I understand what is normal, I can understand what is abnormal. So that way, first of all, we create a baseline. That baseline is all the collection of logs, all the collection of packet flows and things like those. We create a baseline. The automation there is just collection and data monitoring and pushing of the data, right? The second layer of cool automation is where now we can use a machine learning there, strip out all the noises, and give specific instructions to users on what to do with these anomalies. An example would be data exfiltration. We see that there is no data going out of this specific port to any specific IP addresses. Suddenly, one day we see thin stream of data going continuously out of the data center or out of a specific laptop. Then we say that is an anomaly, because for so many days or months there was no data going out of that port. Now here is where automation comes into picture. We create a rule set that if that is happening, should we shut down that port, which is dangerous? We should not be shutting down
Yeah.
ports straight away. Should we maybe put that endpoint on an isolation layer in terms about on-prem, call that virtual LAN, where it's purely for emergency purposes. In cloud, we can put that on a virtual net or a VNet, virtual network, where it does not talk to any critical components at all. So that can be all automated. So this is a pragmatic example of what is smart automation. It's not only collection of data
Yeah.
or just making sure that we give them end-to-end visibility, but automating the process of, first of all, data collection,
Yeah.
understanding what is an anomaly, understanding that whether that anomaly is a risk, and then fourth, making sure that we give some steps to the user as to what to do, and fifth, to actually isolate that endpoint directly. So this could be a smart or automation. And I think here is where many automation companies like you
Yeah.
can play a very important role, because um, in today's date, any solution a customer buys, they will only buy if there's a real cost efficiency. There is
Yeah.
gone are the days where people buy for some cool names or things like those. In today's day, when we are thinking about the recession and cost cutting and
Yeah.
cost efficiency, until and unless you provide cost efficiency, none of the customers are interested in the solution. So, in short, those would be my pragmatic examples.
Yes, thanks a lot. Actually, it sounds really like our platform a lot, and I can say that we're doing like a lot of but you said like from collecting, not just not collecting, but also root cause analysis and impact analysis also, and it is, I think, like the really revolutionary way like to investigate what's happening and how you can fix it, like not without like a lot of alerts or like chasing manually what is happening where and what's wrong. So yeah, I hope, and actually I need to say, just shameless promotion, that our solution is free, so it's like really cost effective I can
Very
say.
good. No, very good.
And
Very good.
yes, and there is like only 10 minutes to set up like first data stream, so it's not need
Very
to
good.
like to spend a lot of time on it also. So let's move to another question. I have
Sure.
a few more questions, and we
Sure.
will like wrap up our session. And
Sure.
my next question is about how to monetize security. We talked
Yeah.
about it like before also, and I'm really curious what you would like to say about it.
A very good point, right? So, if you look at the market today, and any market you pick, right, there is always some kind of a security offering. You have got either managed firewalling, you have got SLAs for IP, you have got some kind of a managed SOC and things like those.
Yeah,
Um, Now, when I'm talking to these large customers, I see a big trend of many of the industrial IoT use cases,
yeah,
right? There are a lot of companies out there in manufacturing, automotive, transport, healthcare. Take any large industry, sizable industry, you will find that there's a lot of automation from the industrial IoT devices going on. I'm
yeah,
not speaking about small IoT devices or home
yeah,
IoT devices or even the shop point of sale devices. No, I'm speaking about proper motorized industrial IoT devices, right? And we're seeing that many of them have started to understand that there is a requirement to look at the IoT devices itself or IoT components itself. So here what we have done on what we are learning and what we are offering is something called as Defender for IoT, and this is where we are investing a lot. For example, because many of these big industry systems they are missing a key component called as software bill of material kind of vulnerability management. So we don't work with enterprises, we work with the OEM manufacturers directly, like Schneider Electric and things like those, who have
yeah,
those big critical infrastructures. And if you are a service provider or if you are a security provider and you want to monetize security, then having these kind of offers uh, quite strictly managed to all these different customers of industrial IoT is very important. Second area where I see is that if you look at any kind of offering in the market, it's split into three areas. It's called small, medium, and large. Some people call it the SMB segment as well for monetization. What we are seeing and what we have learned is that it's not only the size that matters, the type also matters. So instead of having a filtering of small, medium, and large. Also, the type of the customers. For example, let's say they are in their zero trust journey. How mature are they in the zero trust journey? Do they allow bring your own devices for their employees? Do they have the right security controls? Do they have the access? So not only the size, but the type also now matters. And
Yeah.
that is one angle, I think, which many of the customers should now be thinking about. Third part is all about your cost when you give security as a service. So let's say you want to monetize security, okay?
Yeah.
And let's say you have got 1,000 customers. That is good for you. But your margin is not that high because you're using 10 different vendors. 10 is less. I've seen 50 vendors in some cases.
Yeah.
And you have to operate and manage all separate 50 vendors separately, right? That requires a lot of resources, lot of vendor management, lot of contracts with the vendors to make sure that that is all catered for, and then the resources of the know-how who knows how to do all the configuration as well, right?
Yeah.
Those days, I mean, those companies would still remain, but the margin will get thin and thin and thin, right? One
Mhm.
way how we have helped one of our customers to build this security as a service is to bring all these features on the cloud platform. So we have
Yeah.
got Microsoft Azure, we have got all the security controls on the cloud, and they are inter-integrated. Why is that important? Let's say from the previous example where you've got 1,000 customers and you've got these 50 vendors, many of the customers want multiple features.
Yeah.
And for those multiple features, it requires integration between these vendors for that customer. That does not come cheap. No money, no
Yeah.
honey, right? So they need to pay for it, and right, and they
Mhm.
need to have this integration and allow that to happen for their end customer. But for Microsoft, many of these integrations are in the back end because those
Yeah.
are our own products and are integrated in the back end. We provide that as a service as well. So we have got a service called as MSSE. It's a Microsoft security services for the enterprise, where we manage the security for their enterprises or for the end customers as well. And we're doing that similarly for the service providers as well. And when I say service providers, the mobile network operators and things like those, so that they can monetize on security. So in many cases, many of the security vendors use our features to offer to their customers
Yeah.
as well. So the main advantage here is that Microsoft Azure is a platform vendor. So we allow many of the vendors to be, they are our partners. You pick any top security vendor, they are our partners. Pick a Palo Alto, pick Cisco, pick Fortinet, they are our partners, right? And we work very closely with them. So we have got the capability to offer to our end customer the end-to-end security controls as well. So from the monetization point of view, the margin, the way you address the features, and the way you plan the customers or help your customers plan their end customers, these three areas I think are very important.
Yeah. Actually, it is important. And my next question is kind of also related to that, but a bit in our area. But can you describe, like maybe shortly, how do you choose providers which you use, which you work with? And why I'm asking about it? Because I see how some companies lately stop to use cloud SaaS, for example, because they see that it's like kind of unsafe, because they would like to be like dependent on this SaaS. Because, for example, you started to use something, you deploy it on your infrastructure, and you like can't like influence somehow, can make some impact on what's happening with SaaS, and it's like unsafe if you are like on different levels again. And maybe you have like some opinion about it. How do you choose providers, and how can SaaS companies also maybe become more fitable to this criteria?
Sure, yeah. So this question reminds me of one gentleman. I was working in Vladivostok,
Oh,
where the temperature was minus 35. This was way back in 2005, 6, whatever,
yeah.
7 or 8, sorry, whatever. So, and the temperature was minus 35, and
Yeah.
I was just with, I flew from Greece over there, so I had a very thin jacket, and I had got an inner T-shirt and things like those, and I had no gloves or no cap. And
Yeah.
for the first time, I could feel my head getting cold, right? My head never gets cold, right? And my skin was getting tight. What I learned is that there is no good weather or bad weather. It's
Yeah.
only good clothing or bad clothing. What do I mean by that? And why is that important? In the context of the cloud is that we can never say that on-prem is the best or the cloud is the best,
Okay.
right?
Yeah.
It all
Hmm.
matters on the use case of the customer, right? There is
Yeah.
never saying that, okay, the cloud is the best thing or the on-prem is the best. Then we also have got on-prem offerings, right? The point is that we have to cater for different kinds of customers.
Yeah.
For the majority of the customers who will go towards the cloud is not because they love some vendor, it's because that cloud vendor is giving them the power of cost efficiency, which is very much
Yeah.
required today, and where they want to go ahead with them. For example, we have got deals with governments, right, with big enterprises, with big mobile providers. It's
Yeah.
because they see some value added with the end-to-end security layers or things like those. Then you will
Yeah.
have some kind of vendors or some kind of customers who are very much ad oriented and things like those. Google does a very good job of monetizing their ad, right? Nobody can touch them in that area, right? Very
Yeah.
smart, and they have got this Google concept, they have got this Google Maps, they've got a lot of areas, and some customers are happy with that, right? Some customers need not go to the cloud. They are happy with going being on-prem. They want to
Hmm.
keep the cost low, and that is what they do. Many of the times, if you I have not yet come across a customer who went to cloud and came back. I'm sorry, but let me take that example where you had a customer or somebody go into the cloud and came back, maybe because they did not plan the use case what they want to do. They went to the
Yeah.
cloud because they went to the cloud, or some very good sales guy forced them to go to the cloud, right? So 99%
Yeah.
of the sales guy's job, right?
Hmm.
In those kind of circumstances. But to be honest, there is no silver line in what should be.
Yeah.
It depends on the use cases completely, right? Now, speaking about the SaaS model, right?
Yeah.
The software as a service, not
Yeah.
SASE, secure access, secure edge. No, we are speaking
Yeah.
about the SaaS, right? For the SaaS model, cloud provides a lot of benefits,
Yeah.
right? The first thing is that whenever you go with the cloud providers, they're going with the marketplace. So if you want, again, depending upon the use case of the SaaS solution, right?
Yeah.
You want a SaaS solution to have plenty of integrations and time to market and easy adaptability. You need to have the integrations with those 100, 200 partners to allow that scalability. Okay.
Yeah.
If you have a SaaS application by itself, it's not a SaaS application. It is just a virtual machine which people can access and across the world. It's not a SaaS solution. A real SaaS solution is which needs integration with multiple solutions and partners. Here is where the marketplace comes in, right? If you look at the Azure marketplace,
Yeah.
AWS marketplace, Google marketplace, you'll see the type of marketplaces might slightly be differ, but 90% all the partners have got on the marketplace. So for the
Yeah.
SaaS modeling, I really think that cloud offers a very good control of time to market and having this integration. Last but not the least, security, right?
Yeah.
And the reason is because let's say you've got a SaaS application which is talking to millions of devices, okay,
Yeah.
millions of phones, for example. That is my SaaS application. If I want to attack millions of devices, I'm not going to go into each of those devices and put a malware. No, I
Yeah.
will attack the SaaS application, and with that access, I will attack the entire millions of database. Only thing they can do is remove the connection of the SaaS from the cloud, that SaaS application from the cloud, which is taking out the wire from their data center server, right? So um, it is all depending upon how you implement it. So if you follow the well
Yeah.
architectured framework, if you have a proper security policy, if you're working closely with the vendor, so Microsoft has got the consultancy teams where we work very closely with the partners as well as with the customers to make sure that they have got the right security blueprint. Number one thing in any deployment is architecture, security architecture blueprint. So if you have the blueprint, you exactly know the call flow, where the packets are going, where should I have some extra access control. For example, on an API call, there is no need to have a RBAC or a access on the API layer, right? there's no specification anywhere. But as a security control, you would have authentication mechanisms on the APIs as well. If it is a non-API call, it should be it should be IPsec, for example, which provides you encryption and authentication. So
Yeah.
that is how a security architecture should be designed. And once you have that blueprint, I think SaaS would be very, very secure. And for the people who are going back to on-prem for some reason, I'm still to meet those customers. But if there are some people, I would love to have a chat with them and see what is the story. But with my experience, this is what I can share, Kate.
Yeah, thanks a lot. Actually, I have like one last question, and it is really, really huge question. I can say that you can like I think one more hour or even a couple hours talk about it, but maybe you can shortly give some advices for our listeners, attendees, how to prevent security incidents in cloud.
Well, right.
It
So,
is huge question. Yeah.
so look at okay. So let's talk about cloud. Cloud is a data center. So
Yeah.
when you use Azure or AWS or Google, it's a data center in some country, right? So if you speak about security incidents on the cloud, we're speaking about applications which are attacked by DDoS or having a malware incident and things like those. 95% of the cases we are seeing is coming from the IT infrastructure with improper
Yeah.
controls. What do I mean? Let's say you are enterprise X, you have got a cloud deployment, you have got also cloud deployment for storage, for logging. Also, let's say you're a customer who does streaming services. So you got all the videos, movies, series, all in a big storage and things like those. And you have got communications between those your servers with each of the endpoints who's talking to that specific server, right? The security incidents on the cloud are multifaceted or multiple phases to it. One phase is the attack on the data centers itself,
Yeah.
right? So you can we can never avoid any attack. And that is a
Yeah.
very wrong word to use. The right word would be how to mitigate it, right? If there is an attack, how can I make it expensive for the attacker that it does not think about attacking my data center? Because not all attackers are real hackers. There are many of them are script kiddies. They pick up scripts from the darknet, make some modifications, and try to do some DDoS or things like those, right? So we should create a very strong architecture of security around data centers, including TVAs like TVRs, threat vulnerability and risk assessment. We should have proper red team, blue team kind of actions on the data centers and on the IT infrastructure as well. Then speaking about access control. So if you look at many of the recent cloud security instances, it is not because of any data center attacks or things like those. It's because of somebody from the IT team, from the IT, some employee has opened some email having some kind of a malware,
Yeah.
then has got a lateral movement, does the privilege management, has access to the admin layer, swaps out the entire access layer, right? Boom, done, right? But
Yeah.
those components are in the cloud. So it is seen as a cloud attack, but the attack is not from the cloud, it's from the IT management. So I think be it on the cloud or be it on-prem, we should really, really have a strong security blueprint with very strong access security, right?
Yeah.
95% of the attacks, access, right? It is all about building a strong access and authenticating and re-authenticating the user. You can put a cool word to it, like zero trust access
Yeah.
or granular access. But the real point is that to have a multi-layered authentication mechanism, so not only one way of authenticating, not stop using SIM OTPs as well because it's not safe as well. You should actually use some kind of a password manager or an authentication manager
Yeah.
where you're not using your passwords anymore, right? So there are multiple layers there, passwordless kind of mechanism using the fingerprinting, not the face as well, because
Yeah.
using a face is not the right mechanism. That is why Microsoft stopped AI work on face identification and things like those,
Yeah.
because it can be going towards racism or things like those. So we care about that. And fingerprinting, for example, could be a good use case. So access security, extremely important. And go with a cloud provider who has got security as a foundation. Look at what controls you need. Look at what are your use cases from the business side as well as a security side, and see where it makes sense. For example, right, we have got cloud providers who give you the basic security, but the time you want end-to-end visibility or anti-DDoS or firewalling, you have to pay for some security vendor who has those kind of things. So do you need those use cases? If you need those use cases, look at different cloud provide vendors who has got that as a feature. You need not
Yeah.
buy a vendor's boxes. Maybe there's a marketplace where there's a closer license bundling, for example. So a lot of things to consider. And as you rightly said, this is a more than a 1 hour conversation,
Yeah.
and it can be a debate. Some people might
Yes.
not agree, and some people might be disagreeing or agreeing. So I think,
Yeah.
if you ask me, it's all about having the right security architecture,
Yeah.
and most of all, making sure that you have got the right access layers in your IT teams as well. 95% cases, somebody is clicking on the wrong email.
Yeah. Thank you very much. Actually, I think it was a really great conversation, and me personally learned so much through this hour and 10 minutes. So thanks a lot for joining us and sharing your knowledge. And it is really great because we actually touched so many topics inside this main topic. And I hope that people who listening to us right now or will rewatch this video later will learn a lot also. Thanks a lot.
Yeah.
And
Thank
I
you
need
very much. Sorry.
yes, and I need to say like a couple words like it's from organizational part that we will send recording to all people who register to the event, and we will glad to see you another event. So please have an eye on our announcement. And actually, I will think about this panel about preventing like security problems. Maybe we'll organize that also. So thanks a lot for your conversation and for this idea also.
First of all, Kate, thank you very much for having me on the session. I like the way you have put across all the questions, and I think you're doing a great job for the community. So, thank you for the great work, Kate, and I hope to talk to you soon. And
Yes.
thank you for the interesting conversation. Really appreciate it.
Thank you and goodbye.
Cheers. Bye bye. Have a good one. Ciao, ciao. Bye bye.
Yes. Bye.